Hello, my name is Aramis Simon, and my topic for this presentation is electromagnetic levitation. So to begin, I'll just give a brief explanation of what electromagnetic levitation is, also known as just magnetic levitation or maglev for short. So maglev is essentially just the process of using powerful magnets to suspend or propel objects without the need for any sort of physical contact, whether that be through rails, cranes, or anything of the same manner. Uh, Maglev essentially just removes all the need for it, as shown in the picture where the apple is floating in the air without any sort of physical object touching it, other than, of course, the metallic portion beneath it, which the magnets interact with to give it the levitational property. So, to explain how maglev relates to electromagnetics and the topics that we've covered in class, I'll be using Lenz's law and Faraday's laws, which their equations are shown on the slide shown, to relate the two. So as we know, induced currents occur when there is a change in the magnetic flux through a conductor that has current flowing through it already, and that current that flows through it produces its own magnetic field. Lenz's law tells us that due to the magnetic field that the current produces through the conductor, in return it produces an induced magnetic field, which goes against the magnetic flux. And this induced magnetic field produces this repulsion force that allows for the existence of maglev technologies. So, to show some of the possible technology that can be created with the use of magnetic levitation, I will first talk about these two examples shown in the slide. These two examples are high-speed elevators and maglev roller coasters. And to begin with high-speed elevators, as talked about in the slides before, by using the repulsion force produced by the induced magnetic field, one day in the future, high-rise buildings can implement these high-speed elevators to move between floors at a speed incomparable to modern-day elevators, which require the use of pulleys. And theoretically, these high-speed elevators with the use of maglev technology can move at a speed that will reduce much more time compared to, again, modern day elevators. In the same vein, maglev coasters also open up the possibility for even faster rides that can possibly even go off rails for some extra exhilaration, since the magnetic forces will be able to move it at a certain angle and be able to, once it reaches contact with the rails again, keep it steady on the track to prevent any accidents that could occur at impact. Or should I say re-entry, since there is no physical contact. Now, to show a real-world example of maglev technology being implemented, I will be talking about the Shanghai maglev train located in China. Now this train, as shown in the picture on the slide, has a top speed of over 430 kilometers per hour, or 267 miles per hour. It also holds the title of the world's fastest commercial train. To compare, the fastest train that has no magnetic properties and just uses steam and the rails goes as fast as 350 kilometers per hour, or 217 miles per hour. Thank you for watching.